Hello everyone. Today let's solve the problem number 144 binary tree pre-order traversal. Previously we solved the problem binary tree in order traversal, right? So today we'll be solving the problem binary tree pre-order traversal. So what the question states here, we are given the root of the binary tree. All we have to do is return the pre-order traversal of its nodes values, right? So this is the question. So basically pre-order traversal is of the order, just give me a second, pre-order traversal follows the order root followed by this one, what do we call, left and then right, root followed by left and then it's right. So in order, left node then right, left node and then right, this is in order, right? So previous problem what we had solved. So now we are solving the we need to return the pre-order traversal of the nodes values, right? So we'll be they have strictly asked us to solve, go with the pre-order traversal. So pre-order traversal follows the order root then left followed by right, right? So I hope this part is completely clear. Just keep this in mind, right? So here let's come to the example 1. Here root we have been given 1 null 2 and 3, 1 null 2 and 3 here. So the output that we need to get here is 1 followed by this one root. So here we don't have anything, so we'll go with 2, then left we have 3, then we have 3. So the output has to be 1 2 3 accordingly with the this one pre-order traversal. 1 left we don't have anything, so we'll go with the 2, then we'll check for this thing left we have 3, the leaf node, and here we don't have anything, so this will be nothing, null or nothing. So here this will be 1 2 and 3. So the output that we got here is 1 2 3. So this is fine. So I hope the first example is completely clear. Next let's move on with the second example. Here we have 1 2 3 4 5 null 8 double null 6 7 9, right? So here 1 we have, then left, then right, right? So we have to go with the 2. For the 2 we have the this one, what do we call, leaf node. So we will be considering 4 and then 5, 4 then 5. Next for the 5 we have this one, still we have the subchildren. Just give me a second here, 1 second. Yeah, for the 5 we have the subchildren here, right? So here in this case we'll go with next 6 7. This will be 1 2 4 5, then 6, then 7. Next we are done with the this part, left part. So then let's go with the right node. This will be 3. We will check for left node. Left node we don't have left, this one left node, so we will go with the 8. Next we have 9, so we'll stop here. Next we don't have anything, so we'll stop here. So the output would be 1 2 4 5 6 7 3 8 9, right? 1 2 4 5 6 7 3 8 9, as I've said, right? I hope this part is completely clear. We just have to return the pre-order traversal, right? So we just have to return the pre-order traversal of the node value they have given. So this is fine. We are done with the example part. And one more thing, they have asked us to do it iteratively rather than this one, rather than going with the recursion. See here, follow up, they have said a recursion solution is trivial here, so can you do it iteratively? Yeah, let's go with the stack and iterative stack rather than the recursion. Let's go with the iterative stack approach, right? So let's discuss the approach quickly. I hope the question part is completely clear. Let's discuss the approach very quickly, followed by the complexities, and then let's write the code. So for the approach part, let's consider the first example, this one, right? So here we have 1 2 and 3. First what we'll do, as I've said, we'll be making use of the iterative stack here. So we'll start at root 1, this one we'll start at root 1, right? So we'll start at root 1 1. We will add this one to the result array. So we can just consider answer array, result array, anything, right? So we'll be considering extra array to store the result. We'll be considering extra array, so this one will be storing this one in the result. Now we have 1 on the stack, 1 on the stack. Next what we'll do, we'll go left as it is, this one, as I've said, this one, pre-order traversal follows the order root left and then right. We have to check for left, left we don't have anything here, right? So then we will skip. Second step is we will skip because we don't have the value, or we don't have the left node at all. Then we will check for right. We have the value 2 here, so we'll go to the this one, node 2, and then we will add this one to the result. Now the stack consists of this one, 1 and 2, 1 and 2, right? So this is the third step. Next we will check for the left, right? So here we have the node 3, we have the node 3 for the 2, right? So what we'll do, we'll add 3, node 3 to the result, and the stack consists of 1 comma 2 comma 3, 1 comma 2 comma 3, right? So this is fine. The next step is we don't have any more left or right, right? So we don't have any more left or right here, so we will stop here, we will stop here. So in the stack we have now 1 comma 2 comma 3, 1 comma 2 comma 3. So we will return this one, we'll return this one. So the output that we got here is 1 2 3, which matches the output that they have given for the example 1 in the question, right? So this is the approach that we'll be going with, right? So first we will be pushing the root to the stack, then we will pop from the stack, then we'll add that one to the result, then we will push right first, then left. Stack follows the order leaf form, we know that, right? Last in first out. So left is processed first, left is always processed first. Just keep this in mind, right? So this is it for the approach. So I hope the approach part is completely clear. Next, as we are completely familiar with the approach, let's discuss the complexities part. So what will be the time complexity here? The time complexity would be big O of n. Why it is big O of n here? Because we are visiting each node exactly once. We are visiting each node exactly once here, right? So overall time complexity would be big O of n, right? So overall time complexity would be big O of n. So what would be the space complexity here? Space complexity would be big O of n as well, because we are making use of the stack, and stack in the worst case or for the skewed tree it takes big O of n. We might have to store all the all the values of the node. So the space complexity would be big O of n for the skewed tree, as we are making use of the stack. So we will be going with the iterative stack rather than the recursion. So they have mentioned that recursion stack is trivial here, so just go for the iteration. So we'll be making use of the iterative stack. So this is fine. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n, right? So now as we are completely familiar with the approach and this one, what do we call complexities, we are good to write the code. Let's start writing the code. Initially let's we have to store the pre-order traversal result, right? So let's go with the result variable. So I'll just go with the list here. This will be integer, so I'll just make use of the result variable. This will be new array list, new array list. This is fine. Let me come out of this one entirely. After storing the pre-order traversal result, so if the tree is empty, we have to return the empty list. So this is the base case, right? So if the tree is empty, then we have to return the empty list. So I'll just go with if the value of the root is null, then we have to return result. We have to return result. So this is fine. The next step is we have to go with the stack to simulate the recursion. We have to simulate the recursion, right? So for that, we'll be going with the iterative stack rather than the recursion. So we will be simulating the recursion iterative, basically. So let's make use of the stack here. So I'll just go with stack. So this one will be tree node stack. This one will be new stack. New stack. This is fine. I hope this part is clear, man. Also we have to start with the root. Basically we have to start with the root itself, right? So I'll just go with, we have made use of the variable name stack, right? So this will be stack dot push of root. We have to start with the root, right? So this is fine, I think. Let's move on with the further steps. So let's write the simple while loop here. Stack shouldn't be empty to process further, right? So here I'll just go with stack dot is empty, stack dot is empty. So this is fine. Within the while condition, what we'll do, let's pop the top node from the stack. Let's pop the top node from the stack. So this will be tree node. This will be stack.pop. Stack.pop. This is fine. So let's go with the next step, or let's move on with the next step. We have to visit the node, or we have to go with the root part of the pre-order. Nothing but here I'll just write result dot add of this one, node dot value. This is fine, node dot value. So next thing here would be, so we have to push the right first, then we have to push the left. As we are going with the stack, we have to push the right first and then push the left, right? So here, this one we have discussed during the approach itself. We will be pushing the right first, then the this one, then we'll push left, because left will be processed before the right due to the stack, right? So stack follows the LIFO. Stack follows LIFO, nothing but last in first out. So that is the reason we have to push the right first rather than left, right? So we will be pushing right first, then we will push left. First, let's push the right. So here, if node dot right not equal to null, what happened here? Twice I have given if. So I'll just write this one quickly. Not equal to null, then I'll just go with stack dot push of this one, node dot right. This is fine. So let me copy the same thing here. Instead of right, this will be left, node dot left not equal to null. This will be node dot left. This is fine. So we have successfully pushed right and left. Now we are done with only, we are left with only one step. The last step would be, we have to go with the final pre-order traversal list, right? Or we have to return the result here in this case. So I'll just go with return result. So this is it for the code. Just give me a second. Yeah, this is it for the code. Let me format the code once and let me hit the run button. So I hope this works. Let's see. So you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed once the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.